Guys, we're back for part two of your lesson on volume. So yeah, just a quick little review about volume. Volume we talked about yesterday being how much space does something take up, and of course we learned that it's a three-dimensional unit of measure. It's got length, width, and height to it. All right. So knowing what we learned from yesterday, we're going to move on today to two more learning goals. Today we're actually going to get into like the math part of things, like calculating things. So goal number one is I can calculate the volume of a rectangular prism given all three dimensions, the length, the width, and the height. And your second learning goal is I can construct a rectangular prism with a given volume. Yes, this is another word. Construct is another word for build. So yeah, by the end of today's lesson, you should be able to build a rectangular prism if I give you a volume, all right? So let's just get into the calculation bit first. Now, I don't know if you remember all the way back to when we were learning about area, like if I were to ask you to calculate the area of a rectangle. To calculate the area of a rectangle, you just had to multiply the two dimensions together, the length times the width, right? So with area being a two-dimensional measure, we multiplied the two dimensions together. And it's very similar with volume. Volume was a three-dimensional measurement. It involved length, width, and height. And to get the volume of a rectangular prism like this, you're just going to multiply those three dimensions together, length times width times height. And again, guys, it doesn't really matter which side we label the length and which side is the width and which side is the height, because with multiplication, order doesn't matter, right? If I go 2 times 1, that's the same thing as 1 times 2, and it doesn't matter what order I put those numbers in, we're going to end up with the same answer anyway. So it's the same thing here. It doesn't matter what order we put these in or which side we call what. We're always going to end up with the same answer no matter what. So let's do one example together. Over here, I'm just going to write down my equation. Volume equals length times width. Actually, you know what? There's got to be a better way to do this. Oh yeah, you know what? I was smarter than this before I even started recording. I went in and pre-programmed all the answers just to save time on writing. So you're welcome. That's my gift to you. So yeah, we're going to start by solving these problems by writing our equation. Volume equals length times width times height, just like that. On the next slide here, we are going to plug in the values that we know. And again, I'm just going to call this 10 here the length. When I think of length, I think like the long side. So sure, why not? Let's just put in our 10 inches as our long side. And then width would be our 3 inches here. And then our height would be the 4 inches here, 4 inches tall. So we'll plug all three of those values into my equation. And again, I just want to remind you, you probably should include your units in there as well. So in this case, we're measuring in inches, okay? Now, in order to do this, I mean, lazy mathematicians may reach for a calculator. I'm going to strongly encourage you to see if you can solve these in your head. And a few strategies, you know, I might pick, well, I know that 10 is a really easy number to multiply by, so I might save that one for the end. So I'm just going to go 3 times 4, and I know that that is 12. And then 12 times 10, I know would equal 120 inches cubed. So there we go. There's my answer. I have my units with my three-dimensional measure, or my three-dimensional unit beside it, 120 inches cubed. So that's how much space this rectangular prism would take up, all right? All right. Well, so that's how you calculate the volume of a rectangular prism, and that knocks off the first learning goal that I gave you today. But we still have one more learning goal that we have to cover, and that is how to build or construct a rectangular prism with a given volume. So before we do that, I just wanted to show you, like on the left-hand side here, we've got a rectangular prism. And if this was all folded up paper, made out of paper, you could actually deconstruct that rectangular prism into a flat two-dimensional shape. And that flat two-dimensional shape would look like this on the right. This figure on the right here is called a net. A net is a shape that you can fold up into a three-dimensional shape, okay? And what I want you to notice about this is this shaded gray face of my rectangular prism, that would be the bottom of it, would have dimensions of 3 by 2. right? And over here on the net, we can see that this little tab here, let me just grab a pen to mark it off here. This little tab that I'm kind of coloring on right now is 3 by 2. And I know it doesn't say it right here, but up here, it does tell us that this is 2 centimeters over here. So we can kind of just fill in the missing information with other parts here. This would be our 3 by 2 tab, which is the bottom gray one here. If I grab a different color, we'll make let's make this the front face here, the one that would be closest to us if we were looking at this straight on, would be 3 by 6, right? It's 3 centimeters wide, and then we know that it's 6 centimeters tall. They give us that measurement up the side. So that would correspond to this face right here, 3 by 6. And then the side face, and if I can just grab one more color here, the side face here would be 2 by 6. All right, and so we can see that on the net over here, they tell us that this little section here is 2 centimeters wide, and again, the height here would be 6. So I'll just shave that in for you as well. And so you can see that all 3 face sizes are present in my net. And of course, we would have a front and a back that are both equal in size. We'd have a left and a right. So let me just color this in for you. You can see that the left and the right are both going to be 2 by 6. Grab my blue pen here again. The front and the back are both going to be 3 by 6. And then the top and the bottom are both going to be 3 by 2. All right, so that's the way a net works. Opposite sides of your rectangular prism are always going to be, they aren't going to be side by side, but they're going to be kind of like every second face on here like that. They'll never be side by side. Okay, so that's what a net is. And that's how it corresponds to the 3D shape over here. So now I'm going to give us a little problem. And the problem says, make a rectangular prism with a volume of 16 inches cubed. Now, when we're calculating the volume, remember, we're multiplying 3 dimensions together. We're going to multiply the length, the width, and the height. So what we need to do is come up with a list of ways that we can multiply 3 numbers together to get a volume of 16 inches cubed. Now, I've gone ahead and I've done that for you. You can check out my work here and see if you agree with me. And also, if you think I've missed any, you can let me know that as well. But if you go 1 times 1, well, that's 1. And 1 times 16 is 16. So here's 3 numbers multiplied together that gives us a volume of 16 centimeters cubed. You can check the other 3 on your own. What I wanted to do, just to save some time, is and this is the beauty about this exercise here, is that there's actually more than one correct answer, because all 4 of these possibilities will give us the same volume, but the rectangles are going to have different dimensions, or the rectangular prisms, sorry. So I'm just going to pick one of them. I'm going to pick this 2 by 2 by 4 down at the bottom here. We're going to construct a net out of those dimensions that you can cut out and fold up to make your very own rectangular prism, okay? So those dimensions, 2 by 2 by 4, and what you need to do is you need to take all 3 possible combinations. So if we take the first 2 numbers and multiply them together, or use those as our dimensions, that would be 2 by 2. You can see that this arrow here is red, and that corresponds to my square down here on the left side. This, using a ruler I've measured, is 2 centimeters tall and 2 centimeters wide. So there's my 2 by 2 dimension. And then if we take the second and the third dimensions here, 2 by 4, that would give us a rectangle that is 2 by 4. So again, it's got the height of 2, but this one, if we look on the ruler, it goes from the 3 to the 7, which is 4 centimeters, right? Okay, and then we'll take the first and the last dimension, 2 by 4, and we'll make another rectangle out of those dimensions as well. And that just happens to be the same as the blue ones here. It's not always going to be that case, but in this example here, yeah, we've got a couple of faces that are going to be the same size as each other, okay? So using those dimensions, we've created our 3 different face sizes. And then what we want to do is, remember we said that these face sizes always come in pairs, because the top and the bottom will always be the same size. the left and the right will always be the same size, and the front and the back will always be the same size as well. So I've gone and I've made duplicates of each of those sizes. And then what we want to do is we want to arrange them into that net formation. And it should always look like a T when you're done. So here's what I've done. I've taken them and I've put my front and my back not next to each other, but opposite sides to each other. So my two green ones are here. And then same thing with my blue faces are here. And then my my left and my right side, my 2x2 faces, I've just stuck on the side. And it turns out if we were to cut that out, so you can see I've added in a little dotted line around the whole shape, and that's where we would want to use our scissors to cut out here. We could cut out that shape, we could fold it all up, and that would, if we taped it together, would make a rectangular prism that would be 2 by 2 by 4 centimeters in dimension, and the whole volume of that would be 16 centimeters cubed, okay? So that's how you would go about making or constructing a rectangular prism with a given volume. So that's our two outcomes for today, calculating the volume and building a rectangular prism with a given volume. So now it's your turn. Actually, I'm gonna give you a couple of options to do today. You don't have to do both of these. You can choose one or the other, all right? So option one, if you prefer doing just like the calculating part of things, you can complete IXL grade 5 skills Z8. This is a really good skill to help you practice multiplication of bigger numbers as well, because you're going to be multiplying 3 digits together, 3 dimensions together. So your numbers are going to get a little bit bigger, and it's just great practice all around for multiplication, as well as calculating volume. And then option 2 is build your own rectangular prism with a volume of 32 centimeters cubed out of paper. And yes, this will require you to go through those same steps that I walked you through. You're going to have to figure out all your possible combinations that will give you 32 centimeters cubed. You're going to have to pick one of those possible combinations, and then you're going to have to calculate or figure out the dimensions of each face and put those faces together into a net. All right, and so yeah, so your task there would be to take a picture of your net before you cut it out, and then also to cut it out, tape it all together into a 3D prism, and then take a picture of that and send me both of your pictures. Okay, so that's your lesson for today. That's your activities for today. Hopefully you can choose one or the other, whichever you think you would need the most practice at, or whichever one you think you would enjoy the most. And I'm good. All right.